Okay. Now, personally, this I consider this code less desirable. It's unnecessarily confusing. And my own preference would be to create a function that's called like clip to limits. You would call it clip to limits with a minimum, with a maximum, and with a and with some value, and it will clip that value to those limits. Do you want to see that? Do you want to see how functions are done in AnyLogic? Let us view that. So if that's okay, I'm going to take this down now, and I'm going to go apply it in a function. Okay. Okay. So, ladies and gentlemen, to add a function to AnyLogic, to clean up that mess, that unseemly site that just presented itself, we want to go create a function. Okay. So we're going to go up here. We're going to drag in a function. And this is going to be, clip to limits or something like that. There may be some ways to find it. So those folks from computer science, show your prowess. Demonstrate it. So what does this function return? It's going to clip a value to lie within a minimum and a maximum. It returns a double. Good. The prowess is showing. And what does it take as arguments? 3 things. A value to be clipped. Right? Okay. So value to clip. And that could be a double. Could it not? A double. And then what else does it take? Well, some minimum value. Minimum legal, and I'll call it a double as well, and some maximum value. Okay, some maximum value, maximum legal value, double. And having done that, and I'll come back to the screen in a minute, ladies and gentlemen. Having done that, I can go define the code. Okay, so what is this code? Well, it's very similar to this code we have here. So it's a minimum with this is the minimum here. So this would be minimum legal. Then there's a maximum. This is, and here is occurring with respect to maximum legal. And then there's the value to be clipped, right? Value to clip, okay? So this function now takes care of sort of the actual grungy work of applying this. Okay, so there needs to be a thing here. I'll go as one should. I'll go and compile this thing. It built successfully, and now to use this function. Well, okay, I'm sorry. I'm actually going to reflect one more thing. And for this, I asked that the prowess of the computer science students be shown. Does this function need to be a method? Or is this something closer to a pure function? So there's a notion in... It doesn't need to be a method because it's not operating on this particular person. You could call clip to limits for certain values, those 3 values, you could call it, and it'll return the same value regardless of who you're calling it on, right? Whether you call it this person and that person, it really doesn't need to be specific to a person. It's like the sine function or the tangent function. It's not specific to a person. It's a more mathematical quantity. See, we declare it static. It's associated with the whole class of personhood here, fine, but it's not really specific to a person. Okay, it doesn't have to be. It doesn't behave differently depending on which person you use it for. It doesn't have to depend on the characteristics of that person. Instead, it's defined statically. Does that make sense? Okay, so from in motion, how would I then apply this? Well, I could do clip to limits, right? And to limits, and I will give it as its first argument. The value to clip will be the current value plus this perturbation. Okay? What's the minimum value? 0. And the maximum value is get width. Okay, clip to limits. And similarly, I'm going to do it here, except it's get y plus this normal value. Okay? And this should be get height here. Does that make sense to people? So now I have to find a function which accomplishes the conceptual task of clipping this value, ladies and gentlemen, whatever value is passed in here, it clips it to lie within this 0 and lie within this height. Okay? So it works for both of these. So that cleans it up and makes it kind of a little bit clearer what's going on here. And with that, ladies and gentlemen, I will compile this code. Oh, I already did. I will run this code. And we see these agents evolving in a way that might warm a physicist's heart. Okay? So here's the use of a function. In this case, it was a static function. It didn't depend on the particular agent. There might be some other function that does depend on an agent's state. Might have a function get age, or you might have a function that has them give birth to a baby or something like that, in which case there'd be a function which does something with that person. Here, because it doesn't depend on the agent, we use the term static. But as in AnyLogic static event, dynamic events versus regular events, this term static is a little bit confusing. It means it's not associated with a particular person. It's associated with the person class. It doesn't depend on the characteristics of the person. Does that make sense? Yes, Farhan.
Here we have the code on InMotion, yeah?
Yes.
Why we didn't use it for example, for transition?
This transition?
Yeah.
Because it would have had to have been here and here. Because we'd have to start the moving here, this incoming transition, and we'd have to, again, move them here. So it was easier to put it in a single place when they enter the state, and they enter the state either coming in here or coming in here. So
I think of movement as a transition.
Right.
So in my mind, I think it should be on transition.
Okay.
We have a state
Yeah.
motion for each agent,
Okay.
for each person.
Yeah.
But each movement is kind of changing something for agents.
Sort of. Okay. So this is a good question. Let me just